Bismillahirrahmanirrahim. Dear students, welcome back and Assalamu alaikum. Today we are on online lecture number 12 of the Programming Fundamentals course. Today we are going to discuss, our discussion will be on pointers and dynamic objects. So we have already talked about pointers a little bit, but today we are going to dig deeper into these concepts, and we are going to see how they are useful and why they are important in computer programming. So with that, let us see the topics for today's lecture. Today mainly we are going to discuss pointers. We are going to discuss memory addresses, declaration, pointer declaration, dereferencing a pointer, pointers to pointer. And then if we have time, we are going to uh, differentiate between static and dynamic objects. We are also going to study the new and the delete keyword. So with that, let us start the lecture formally. So computer memory has a very vital role when the computer program is running, because the memory addresses or the variables etc all are stored inside the computer memory, and each variable is assigned a memory slot or a memory area, and the size depends upon the data type of the variable and also the architecture of the computer system, and the variable data is stored there. So if whenever you use a variable, so for example, if you are using, if there is a variable called a, so if you declare it as int variable, then uh, a memory slot is created for this variable, and inside memory you save some data, and this memory slot is given a name called a, and it also has an address. So what does it mean? It means that computer has a variable, has a name, data type, and a value and an address. So four things are attached to a variable. So once again, I repeat, each variable is assigned a memory slot. The size depends upon the data type of a variable, and the variable's data is stored there. So for example, you have this memory address. So we have 1020, 1024, 1032, etc. And this 100 value is stored at the address 1024. So this is a name given to this memory slot. So we can say int, we have declared a variable and assign it a value of 100. So this is what it looks like inside the memory. So variable a's value, which is 100, is stored at a memory location 1024. So this is what we have already discussed, and you know about it. But remember, every memory address, every memory slot has an address and has a name, and a variable has a data type, and in every memory slot you can store a data. If you haven't stored any data, then the garbage value will be stored there. Okay, now what are pointers? A pointer is a variable, so it is nothing new. It is also variable, so it means that pointer will also, it's a memory slot, it will also store something. But what is that special thing? A pointer is a variable used to store the address of memory cell. So inside this pointer you can only store the address of another memory cell. So that is what is that is how pointer is different from a variable. Whereas variable stores value, pointer stores the address of other variables. We can use pointers, we can use the pointer to reference this memory cell. So for example, you have this integer data 100, and this is a pointer, and you have stored inside this memory location, you have stored the address of this variable. So the address is 1024. So a pointer is a variable used to store address of a memory cell or address of another variable. So there are different types of pointers. C++ has pointer types for each type of object. Pointers to integer objects, pointers to character objects, pointers to user-defined objects such as rational numbers, even pointers to pointers to integer objects. So we are going to discuss each of these pointers in detail in the next slide. So let us first discuss how a pointer variable is declared. So you write the data type of a pointer and then the pointer name, or you write the data type and then a static is moved towards the pointer name. Here in the first case, static is with this data type, whereas in this case, static is closer to the pointer name or the pointer, whatever you have given name to the pointer. So when where type is the type of data point, so it can be integer, character, or double. So if you are holding address of integer variable, then the pointer will be integer. But if you are holding address of character variable, then the data type of pointer will be character. So for example, you have declared a pointer n, and then we have a rational number. This is another pointer r, and then we have pointer to pointer. So pointer to pointer is declared with two statics. So this is how you declare pointers and you declare pointers to pointers. The only difference is that pointers to pointers is declared, we use two static. But keep in mind that pointers to pointers mean that pointer is holding an address of another memory location. So this is the memory location, and that memory location is also holding address of another integer or float or character object. So this is some value. So this is what pointer to pointing is holding the address of another pointer. That pointer is holding address of some data. Okay, and then before discussing pointers in detail, I would like to discuss the address of operator represented by ampersand sign. The address of operator ampersand sign gives the memory address of a variable. So if you use ampersand sign with any variable, you get the memory address of that variable. So for example, we have a variable a which is storing the value 100, and it has address 1024. If you want to print the address 1024, what you do, you first declare this variable, assign it some value. If you want to get the value, you just simply write cout a, so it will print 100. But if you want to get the memory address, you write cout less than sign ampersand sign or address of operator and then a, so it will print the address which is 1024. All right, so we are going to continue our discussion on address of operator. So this is your memory addresses 1020, 1024, and so on. And then we have a program where we have declared two integer variables, assign 88 to a, 100 to b, and then if you write the address of a is ampersand sign a, so you will get 1024. The address of a is 1024. But if you write the address of b ampersand sign b, so you will get 1024. For the case of a, you will get 1020. So I think it's very simple now. We already have discussed this address of operator and pointer, but here we are discussing them in more detail. Okay, then we have pointer variable. Just as I told you, pointer variable holds the address of another variable. So this is p, it is holding address of 1024, which is address of variable a. So how can we assign the address of variable a to pointer? So first declare a variable a, assign it some value, in this case it is 100, and then we declare a pointer, and at the same time we assign the address of a to pointer p. So if you print the address of a, you will get 1024. But if you, okay, first we are printing the a, you will get 100, and then space, and then you print the address of a, we get 1024, and then we print p. So what is p? P is the value, so the value inside pointer, which is 1024. But if you write ampersand sign p, then it will print the address of pointer, which is 1032. The value of pointer p is the address of a variable a. A pointer is also a variable, so it has its own memory address. Just as you see here, it has the memory address of 1032. Okay, and then we have also in the previous slide we also discussed that we have pointer, even pointer to a pointer variable. So what does that mean? So let us look at the declaration. You declare simple variable by writing integer a. You declare a pointer variable by writing the data type, and then the static and p. So you have declared a pointer, but for declaring pointer to pointer you use to static. So what does that mean? It means that now q has the ability to store the address of a pointer, and a pointer has ability to store the address of a variable. So for example, we have this integer a, it has a value of 58, as you can see here, and we store the address of a in p. So the address of a is 234560, which is stored here, and then we store the address of p, which is 287650 into q. So 287650, and q also has its own address. So pointer to integer. So pointer is pointing to pointer, and that pointer is further pointing to integer. So if we print these value, so first you print a, you will get 58, and then if you use this static with p, so what does that mean? It means that you are uh, you are telling the compiler to go to this address and print the value stored at this address. So you print 58. So because the value stored at this address 234560 is 58, and then you are using pointer to pointer. So what does that mean? You are saying to the compiler that go to the address of the pointer for which I am holding the address, and then the address that is stored by this pointer, go to that address and then print the value. So you will get 58. So for these three cases you will get 58, 58 and 58. Alright, we also have a dereferencing variable, but remember dereferencing variable when used at the declaration has different meaning when as compared to when used with the cout statement. So we can access the value stored in the variable pointed to by using the dereferencing operator. Once again I repeat, we can access to the value stored in a variable pointed to by using the dereferencing operator, which is static. So once again we have these memory addresses, and a has the value of 100, so p has some p pointer has an address 1024. So how to print the value of a using this p pointer. So what we do, we first declare a variable a, and then we assign the address of a to pointer variable. We print a. In this case we will get the value of 100. Then we print the address of a, we get 1024, and then we print p. So p is holding the address, so it will print 1024. But if we write static p, so we will, then this static becomes a dereferencing operator. So what does that mean? It means that it is telling the compiler to go to this address and print whatever is stored at this address. So 100 is stored at this address, so 100 will be printed. But if you write ampersand sign p, it will print the address of this pointer p, which is 1032. Alright, so remember, do not get confused. Declaring a pointer means only that it is a pointer. For example, int static p. Don't be confused with a dereferencing operator, which is also written within a static. They are simply two different tasks represented by same sign. So for example, we have three variables. A is assigned value of 100, B is assigned a value of 88, and C is assigned a value of 8. So now we declared three pointers, P1, P2 and P3. So P1 get the address of A, P2 is not pointing to any variable, whereas P3 get the address of C. So then we assign the address of B to P2. So this means P2 points to B. P2 is holding the address of B variable. Then what we do, we assign the address which is stored in P1 to P2. So it means that P1 was pointing to A. So now that address is assigned to P2. So P2 is now points to A. But if we write B equals static P3, so what does that mean? It means go to the address, and whatever is stored in this address pointed to by P3, get that value. So P3 is holding C, so get that value, we get 8 and assign it to B. So B now will have a value of 8, and then assign C to B. So assign C to B, so B will now have value of 8. And then if we say P2, it means that go to the address uh, um, which P2 is holding. So P2 is holding the address of P1, and at that location we are storing what? So we are storing, so at A we are storing the value pointed to by P3. So P3 is pointing to C, so we are assigning this A to A, because we are saying go to the address pointed to by P2, go to that memory location pointed to by P2 and assign it to what? Assign it whatever P3 is pointing to. So P3 is pointing to the memory location where 8 is stored. So 8 will be assigned to P2. So P2 is holding the address of A. So A, here we will get 8, and here we also have 8. So if we print A, B and C, we will get 8, 8 and 8. So this is how these addresses work. So don't be confused with dereferencing operator, which is also written within a static. They are simply two different tasks represented with the same sign. So here we use this static to declare a variable, whereas in this statement we use it to as a dereferencing operator. So now we have this example. This is the code where we have a main function. Main has a variable a, which is holding the value of 16, and then we are calling double it function. So uh, when we call this double it function, the value 9 is assigned to x. So x gets the value of 9, whereas p gets the address of a. So here p is pointing to a, and a is having value of 16. So what it does, we go to this location and we multiply 2 with x. So 2 multiplied by x is like x has the value of 9, so 2 multiplied by 9 is 18, and we stored that 18 value. No, 2 multiplied by 9 is, sorry, yes, it is 18. Yes, it is 18. So we are storing that value 18 at the location pointed to by p, so the which is the uh, variable a. So all right, so now p was pointing to 8192. Yes, that is correct. X was having value of 9. That is also correct. And a after this operation will have a value of 18. So this is not 16, this is 18, because we are multiplying this 9 with 2. So we get 18, because this is also 18, because after multiplication, yes, here I have written it, after multiplication we get a gets 18. This is before the multiplication operation, but after multiplication a gets the value of 18. And because here we pass the address, so p is pointing to the memory location where a has stored some value which is 16. So p has the address of variable a. Okay, let me check out the time, because okay, we still have some time. Okay, so let's figure out what will be the value 1, value 2, p1 and p2. So this is the program. I would recommend you people to go through it, implement it in code blocks, so you will get a feel of like you have mastered the pointer concepts. So and you fully understand what's going on in this program. So once again we declared two variables, value 1, value 2. Value 1 gets 5, value 2 gets 15. We declared two pointers variable p1 and p2. We assign the address of value 1 to p, so p1 is now pointed pointing to the value 1, p2 is pointing to the value 2. We are storing the value 10 at value 1. So what does that mean? It means that now value 1 will have 10. And then what we do, we also assign this 10 to p2. P2 is holding the value address of value 2, so whatever is stored at the address pointed to by p1 is assigned to the address pointed to by p2. So p2 is pointing to value 2, so value 2 also gets the value of 10. Okay, value pointed to by P2 is equal to value pointed to by P1. And then what we do, we assign P2 to P1. So P1 will now be pointing to uh, like we have this P1, P2. Now both are pointing to the value 2. So I'm just writing V2. And then we are saying change whatever P1 is holding, go to the address which P1 is holding and assign the value of 20 there. So P1 is holding the value of P2, value 2, the address of value 2. So here we are going to replace 10 with 20. And then if you print value 1, so value 1 will have a value of 10, and then value 2 will have value of 20. And what will be inside P1 and P2? P1 will have the address of value 2, and P2 also will have the address of value 2. So we have this another example. The more we discuss example, the more we will understand about pointers and other stuff. Okay, so here we have, okay, let me change the pointer. Here we have variable a. We are assigning value 3 to variable a, and then character s. We are assigning z to s, and then a variable d, which is double. We are assigning 1.032d. And then what we do, we declared a pointer variable pa and assign it the address of a, and ps gets the address of s, whereas pd gets the address of the d variable. So the size returns the number of bytes. So if we write size of pa, so it will return the number of bytes, and then size of the address, the value which is pointed to by pa, and then the address of pa, size of the address of pa, and similarly we print size of ps, the size of static ps, and size of the address of ps, and then we print the size of pd variable. Pd is a pointer, and then the size of the value pointed to by pd, and then the size of the address of pd. So remember, what is a reference variable? A reference is an additional name to an existing memory location. So for example, you have this memory location where you have stored 9. So a reference is another name, it store the address of this memory slot. So we can say that x is the name of this memory slot, whereas reference is holding the address of this memory slot. So x has 9, we have a reference variable, it gets the address of x, so it is pointing to x. So we have x equal 9, we get the reference of x. So now x and reference both are pointing to the same memory slot. Reference variable serve as an alternative name of an variable or an object. So for example, we have m10, we get the address of m and assign it to variable j, because this is here we are using address of operator. J is a reference variable. So if we print m, we will get 10, and if we say j, assign it to assign the value 18 to j. Once again, if you print m, so because j was pointing to this m, so if you change the value pointed to by j, it will also be reflected in m variable, because m was the name given to that memory slot. So if you print the variable m, it will also print it will print 18, and we have indirectly through reference variable changed the value of the variable m. Okay, a reference variable always refers to the same variable or object. Remember that here we are just saying that variable and object are same thing, but later on you will see that there's a difference. Assigning a reference variable with a new value actually changes the value of the referred object. So a reference variable can get uh, one address at a time, but you can change it. You can give it another name. So now that reference variable will be pointing to another referred object. A reference variable are commonly used for parameter passing to a function. Okay, okay, so we are running out of time. I think that is enough for today's lecture. If you have some problem, you can post it on the Google group. I'll stop lecture here, but still if you have some problem, I'll be happy to answer your problem and question. I'll see you in the next lecture. Till then, take care and Allah Hafiz.